Welcome to lesson 23 of GMAT Math Basics. Today, I want to talk about quadratic equations. If you don't want or need help with math basics, please head back in the feed for more advanced topics. We've covered almost every element of basic math tested on the GMAT at this point. So now you're well positioned to understand a more specific and complicated type of equation, quadratic equations. Before we dive in, here's a quick quiz on what we'll cover today. There are quizzes like this at the start of every episode in this Math Basics series, and I recommend quizzing yourself on these at least once per week until you are rock solid with these basics. Question 1. What is a quadratic equation? Question 2. How do you factor quadratic equations? Question 3. What are the roots of a quadratic equation? Let's dive in. What is a quadratic equation? Quadratic equations are special equations that contain a variable that is squared, meaning it's taken to the second power. The term quadratic comes from Latin and roughly means square, as in the shape. I'll skip the history lesson, but I think knowing this one fact is helpful. Otherwise, I don't think it really makes sense why these are called quadratic equations and not just equations with squared variables. So hopefully that's helpful. Again, it's all about having a variable that's squared or taken to the second power. So one of the simplest quadratic equations would be x squared equals 9 or something similar. What's special about quadratic equations? Well, you may or may not notice that the equation x squared equals 9 actually has two possible solutions, and that's a little bit unusual. X could be positive 3, or it could be negative 3. In either case, if we square x, we would get positive 9 as the result. This is important for a couple reasons on the GMAT. First, it's good to remember that quadratic equations generally have two solutions, not always, but generally. And second, it's good to remember that when you are taking the square root of a variable in an equation, like we probably would if we were solving something like x squared equals 9 on the exam, you'll want to remind yourself that you'll usually have one positive solution and one negative solution. This concept is frequently tested on the GMAT. For example, if you simplify a complex equation and then get to the end and see something like x squared equals 16, it's really tempting to think x has to be 4 and that's that. But that's not the whole story. X could also be negative 4, and you want to make sure that you don't miss problems as a result of forgetting that. It's very easy to make that mistake if you're in a rush. Quadratic equations often become more complicated than just a variable squared and another number. So let's talk about how to deal with those kinds of situations. The most common way that they become more complicated is when the equation involves a variable squared along with another term where that same variable is not squared. Let me just repeat that. It's common for quadratic equations to involve a variable that is squared, taken to the second power, along with another term where that same variable is not squared. For example, you might see an equation like x squared minus x equals 2. Here, we've got the variable x squared, but we also have another term where the variable x is not squared, that minus x term. This is extremely common on the exam. Because these are so common, it's important to know how to handle these kinds of situations well. And handling them well generally requires something called factoring. So let's discuss how to factor quadratic equations. Chances are you've learned this in the past. Hopefully, I'll just be reminding you of these basics, but if you're learning this for the first time, I'll do my best to walk through it step by step to make it as easy as possible. When you want to factor a quadratic, the first step is to use the golden rule of algebra to set the equation equal to 0. Again, first step is use the golden rule of algebra to set the equation equal to 0. If you want to factor a quadratic, set the equation equal to 0 first. Let's consider our very first example. X squared is equal to 9. In order to set this equal to 0, we would just subtract 9 from both sides of the equation. This would produce x squared minus 9 equals 0. That's step 1. Set the entire equation equal to 0. Step 2 is to set up two sets of parentheses. These sets of parentheses will be multiplied together, and each will have room for two terms. So we're going to set up two sets of parentheses that will be multiplied together, each with room for two terms. The way this looks is you'll have an open parentheses and then some space for two terms, and then a closed parentheses. Immediately to the right of that closed parentheses, you'll have another open parentheses, which signifies that we're multiplying. And then you'll have space for two terms, and then you'll have a closed parentheses. And then generally, you'll have the equal sign right to the right of that, and then 0 right to the right of that. All right, so we make two sets of parentheses that will be multiplied together, each with room for two terms. The next step is to write the variable as the first term in each set of the parentheses. So the way that would look would be open parentheses, then the variable, which in this case is x, and then space for the second term, closed parentheses. Immediately to the right of that closed parentheses is an open parentheses with a variable x, right to the right of it, and then space for the next term, and then a closed parentheses. So that's our two sets of parentheses with the variable as the first term in each set. And then we have to the right of that equals 0. The last step is you want to find two numbers that add up to the coefficient of x, not the one that's squared. Okay, you want to find two numbers that add up to the coefficient of the variable that's not being squared, and that simultaneously those same two numbers also multiply to the numerical term, which is the term that has no x in it. So we'll talk through this a couple times. It can be a little complicated, so I'll repeat it in a moment. But don't worry, we'll have a couple examples to walk you through this. You want to find two numbers that sum to the coefficient of x. Again, not the variable that's squared. And simultaneously, those two terms multiply to the numerical term, the one with no variable in it. You'll notice that in the equation x squared minus 9 equals 0, there's actually no term with just x in it. And another way to represent that is we're multiplying that by 0. That means that we want two numbers to sum to 0, because 0 would be the coefficient of that non-squared variable. It's not in the equation. It's just x squared minus 0 times x minus 9. You could think about it like that. So we want to find two numbers that sum to 0 and also at the same time multiply to the numerical term, which in this case is -9. So we got x squared minus 9 equals 0. You can imagine that as x squared minus 0 times x, or plus 0 times x minus 9. So we want two terms that will add to the coefficient of the x, in this case 0, and multiply to the non-variable coefficient, the numerical coefficient, which in this case is -9. So can you think of two numbers that sum to 0 and multiply to -9? Hopefully, you're thinking +3 and -3. Once you find those numbers, you'll write each as the second term in each set of parentheses. The way that would look in this case is open parentheses, and then x, and then +3 right to the right of x, and then close parentheses. Immediately to the right of that closed parentheses, we have an open parentheses, which indicates multiplication, and then right to the right of that, we have x, and then to the right of that, we have -3. And then we have the closed parentheses, and to the right of that, we have equals 0. So you have the quantity in parentheses x plus 3 times the quantity in parentheses x minus 3 equals 0. That's the most basic way to factor quadratic equations. There are definitely more advanced ways, such as the quadratic formula, but those are best left for another part of your journey, in my opinion. So for now, let's just stay focused on the basics. We'll also do another example in a moment to clarify this process and make it easier to implement. But before we do that, let's talk about the solutions of quadratic equations. Earlier in our quiz, I asked you what the roots of a quadratic equation are. And roots and solutions of quadratic equations are actually the same thing. The factored form of a quadratic equation will produce what are called the roots or solutions. These are the values of x that make the equation true. In our recently factored quadratic equation, quantity x plus 3 times quantity x minus 3 equals 0, ask yourself what values of x would make this equation true. On one hand, plugging in -3 will make the x plus 3 expression equal to 0. And if we multiply that whole left side by that 0, we would get 0 equals 0. That would make the equation true, and so -3 would be a solution. If you plug in -3, you get 0 as a result. On the other hand, plugging in +3 to the x minus 3 expression will make that part of the equation equal to 0. And then if we multiply out that left side of the equation, everything will become 0. Again, we'll get 0 equals 0. That lets us know that that value of x makes the equation true, and so +3 is also a solution. The key is to recognize the numbers that, when inserted, will make one of the expressions in parentheses equal to 0. That's the key. Those values will always make the equation true because our first step was setting the equation equal to 0. This is part of the reason that we do that. GMAT questions will sometimes ask you for the solutions to quadratic equations. Other times, the exam might ask you for the roots. And you'll just want to remember that these terms mean the same thing. They both indicate the values of the variables that will make the factored form of the equation 0. It's easy to get a little bit mixed up here, so let me just repeat that. If a question asks you for the roots or solutions of a quadratic equation, it is asking you for the same thing: the values of the variable that will make the factored form of the quadratic equation equal to 0. Those are the roots. Now you understand all the basic elements of quadratic equations, so let's wrap up with a final example that pulls all this together. Previously, I brought up the equation x squared minus x equals 2 as an example of an equation that has a variable squared and another instance of that same variable that is not squared. And again, this is a super common way that quadratic equations show up. Obviously, it's not the only way. I just showed you a situation that could be different, but it's worth talking about this specific situation because, frankly, it's more common. So if you see this kind of situation, there is a strong likelihood that you'll want to factor it in order to determine the equation's solutions. This is not always the case. Sometimes you'll want to do other things with the equation in the problem, but most of the time, the vast majority of the time, you'll end up factoring it. So let's walk through these basic steps again and demonstrate each one. The first step is to use the rules of algebra to set the equation equal to 0. We have x squared minus x equals 2. Let's subtract 2 from both sides, and that will give us x squared minus x minus 2 equals 0. And that's what we want. We want an equation with just 0 on one side of the equal sign. The second step is to create two sets of parentheses and fill in the variable as the first term in each. So the way that would look is open parentheses and then x right to the right of that, space for another term, close parentheses, and then open parentheses right to the right of that, x to the right of that, and then space for another term, and then second close parentheses equals 0. Now, the final step is we fill in two values that add to the coefficient of the variable that is not squared, and that also multiply to the numerical value. Let's find the coefficient for the variable that's not squared. In x squared minus x minus 2 equals 0, the variable that is not squared is x. And the coefficient of x is -1. That's why the equation appears to be x squared minus x. We have a coefficient of -1. So we'll want our two values to add up to -1. We also want these two values to multiply to the numerical term. In this case, the numerical term is x squared minus x minus 2 equals 0. And in that situation, -2 is the numerical term. So we'll want our two values to multiply to -2 and also sum to -1. Can you think of two numbers that would fit those constraints? There are only two numbers that will sum to -1 and at the same time multiply to -2, and that's +1 and -2 itself. So we will write those two numbers into the parentheses. That's going to yield quantity x plus 1 in parentheses times quantity x minus 2 in parentheses equals 0. Or, if you prefer my previous way of explaining it, open parentheses and then x. Right to the right of that, you'll have +1, close parentheses, and then right to the right of that, you'll have open parentheses and then x and then -2 and then close parentheses. That equals 0. That will allow us to find the roots, also known as the solutions. So let me ask you, which values of x would make x plus 1 times x minus 2 equal to 0? Hopefully you're thinking that if you plug in -1 for x, that will make the left side equal to 0, that x plus 1 term. And if you plugged in +2 for x, that would make the x minus 2 term equal to 0. And because we're multiplying those two terms together, if we make either one of them 0, the whole left side of the equation becomes 0, and we get 0 equals 0, which makes the equation true. So our solutions would be -1 and +2. That's how you handle basic factoring of quadratic equations. If you want to practice some drills, I recommend asking a generative AI chatbot such as ChatGPT to provide some. A simple prompt like create a 10-question drill to help me improve my basic quadratic equation skills for the GMAT works really well. If you have questions, reach out anytime. You can find us at the GMAT strategy on current social channels, or click the link below and/or in our bio to find clickable links to our social accounts. You can also email us at contact, CONTACT, at thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.